Okay, good morning, guys. Really quick, I want to talk about page 4 and page 5 and 6, but I'll save that for a separate video. Just basically in terms of series circuits and parallel circuits, as we discussed in the notes, you need to set up a VIR table or a VIRP table. Now, generally, we're not always calculating the power of the circuit or of the individual resistor, and because of that, you may not need to fill anything out over here. But I would encourage you to always put all four VIR and P, voltage, current, resistance, and power, for the table. Do not forget that you need to also number the resistors and have a column for total. Okay, so this is resistor 1 right here, this is resistor 2 here, and this total is technically what's reading across the potential difference, or the battery. Now the biggest key, remember that, as I put up here, the same for all is the current. Okay, the current is the same. So if you know the current, you can fill it all the way down. You can just continue to repeat the same value. Or if you happen to know, for example, the total voltage, which is usually something you are provided, total voltage here, and the total resistance, you can calculate the current. And that was relatively easy in this case. I don't know why it's taking forever to erase this, but we were provided a 5 ohm and a 10 ohm resistor, which means that the total resistance is the sum of them, so the total resistance was 15 ohms. Plugged that right in here. We know that the potential difference that the battery provides is 5 volts, so that's here. So the total resistance, total voltage, gives us this current, and then we would just transfer them up, and that's what I did there. Now, since you have the resistance and the current, you can calculate the voltage across resistor 2 and the voltage drop across resistor 1. And always remember your general rules according to the reference table, which we see down here for B through F, really. The equivalent resistance, total resistance of the circuit is the sum. So in this case, we had both. We sum them up. Total current, you have to use the total resistance and you need to use the total voltage. Okay, so if you noticed here, we can't calculate the total current without using the total voltage and total resistance. This is a little similar to using the X and the Y components of parabolic trajectories. We have to make sure we're using the correct components. So if we're calculating the total, we're using the values across the total. If we're calculating the resistance at 2 or location 2 or resistor 2, then we need to use the voltage of 2, the voltage drop of 2, and the current of 2. Okay. Remember that the current remains the same across every item in a circuit for series circuits, and that is because there is only one path for those electrons to travel. This is my battery there. So your electrons only have one path to travel, so they really can't change paths and travel somewhere else, making the flow of electrons greater or less. That is very similar to, as I mentioned, it's a single river. There's no forks in the river, no multiple paths. E, calculate the difference, the potential difference across each resistor. Again, that's just a voltage drop. We discussed that. Remember your total voltage. If you watched my videos from yesterday when I did the demos in my basement with James, we do see some voltage drop. Now, generally when we're doing actual calculations on paper, it's a lot closer. 4.98 was really close to 5 volts. If you remember yesterday, we were supposed to be, I think, at 4.5 volts, and I had on one of my videos 4.1, and then the other video I had really low at 3.8. And what was really interesting is the second video was 3.8, which means those wires may have heated up a little bit, and we may have had a loss in voltage as the material's moving around. I'm unsure of that. One of the batteries could have been on its way out or dying at the time that I plugged in all three to give me the total voltage being almost 0.7 volts lower than what it should have been at 4.5. So it was either was a battery issue or a connectivity issue. Remember, the power is essentially how much work is, if you think about it, being done, and it's in watts. Energy is in joules. Remember that we use seconds for that, so we need to know the amount of time for that. And do not forget that at any point here, we could also ask you how many electrons are traveling through the wire at that point. So how many electrons would be moving across a point in 120 seconds? Now, for example, for number 3, we have a 1 ohm, a 2 ohm, and a 3 ohm resistor. They're hooked up in series with a 12-volt power supply. So the first thing we always do, we draw our little example here. This tells me the total voltage is 12 volts. I plug that in. I create my resistors. Remember that the number of points you have on your resistors does not have to match exactly with the reference table. So you plug in all of your resistors under the resistor column. You have 1, 2, 3. That provides a total of 6. So in this case, you should do the total resistance first. And then the second thing you would want to do is determine the current. And once you know the current and the resistance, you could calculate voltage drop across 1, voltage drop across resistor 2, voltage drop across resistor 3.